Good evening, children.
Good evening, ma'am.
Good evening, ma'am.
Good evening, children.
Good evening, ma'am.
Good evening, ma'am.
Good evening. Good evening, children. Good evening.
Good evening, ma'am.
Good evening. So when do we use distance formula? When do we use distance formula? Why distance formula? So distance formula is used to find the length of a line segment. The length of a line segment. Supposing you have a line segment PQ in the Cartesian plane. That is, there are 2 points P and Q. There are 2 points P and Q in the Cartesian plane. You know the address of P, that is, you know the x coordinate and the y coordinate of P. All right, you know the coordinates of P and you also know the coordinates of Q. Cartesian plane, 2 points, say P and Q. You know the address of P, you know the address of Q, that is, you know the coordinates of P, you know the coordinates of Q. Now, distance formula will help you to find the distance between the 2 points P and Q. The distance formula will help you to find the distance between the 2 points P and Q. Now you might think I'll use a scale and measure. Why the distance formula? I'll just plot the 2 points on the graph paper and use a scale and measure it and give the answer. The thing is, you cannot, accuracy is limited to millimeter in a scale. Well, if you can see example 2, you can see here that the distance between these 2 points P and Q is 6√5 units. This precision you will not get using a scale. Scale will not tell you, scale cannot tell you 6√5. So that is the difference. That is the difference. Okay, if it is exactly 5 units, exactly 5.1, exactly 10.3, that can be got using a scale. But values like 6√5 or 6√2, if the distance, but this is the precise distance between the 2 points, 6√2 units. This you cannot get using a scale. So distance formula. So distance formula. Distance formula helps you to find the distance between 2 points located in the Cartesian plane. Or in other words, it gives you the length of the line segment joining the 2 points. It gives you the length of the line segment joining the 2 points. So when you find PQ using the distance formula, it is the length of the line segment PQ. Distance formula is used to find the distance between 2 points in the Cartesian plane, or it also, or it's the same as finding, it helps you to find the length of the line segment in a Cartesian plane. And you know the line segment connects 2 points. Okay, and the formula, please remember like this, as I told you yesterday. The length of the line segment. So if it is AB, PQ, whatever, CD is equal to square root of difference between abscissa, the whole square, plus difference between ordinates, the whole square. In simple words, square root of, subtract the x coordinates. You have 2 points, right? You have 2 points. So the first point has an x coordinate. The second point also has an x coordinate. Subtract the x coordinates, any order. subtract the x coordinates and square it. Difference between abscissa the whole square plus both the points have y coordinates. Subtract the y coordinates. Any order. Subtract the y coordinates. Any order. Difference between ordinates. The whole square. Square root of, so say PQ. PQ is equal to square root of difference between abscissa, the whole square, plus difference between ordinates, the whole square. So it is the square root of the sum of the squares of the difference between the abscissa and ordinates. Is the formula well understood? We call the derivation. Children must listen to the recording. You can just listen to the recording again. I've shared the recording. So if you want a repetition of the derivation, please use the recording. And we also understood that if we have to find the distance of a point from the origin, the distance of a point from the origin. So say this point P is given by the coordinates x, y. Origin is given by the coordinates 0, 0, represented by the letter O, given by the coordinates 0, 0. So how do we find the length of the line segment OP or PO? PO or OP? OP is equal to square root of, what are the x coordinates? X and 0. The x coordinates, x and 0. Difference, so x minus 0, square it. Difference of the x coordinates, the whole square. So you can write x minus 0 or 0 minus x. Any order, subtract the x coordinates, any order. You can say x minus 0 or 0 minus x, the whole square, plus y and 0 are the y coordinates. Y and 0 are the y coordinates. So difference between the y coordinates, y minus 0 or 0 minus y, any order, subtract them in any order because anyways you're going to square it. So OP is equal to square root of x minus 0, the whole square, plus y minus 0, the whole square. So on simplifying this, you get OP is equal to square root of x minus 0 is x, y minus 0 is y. You can simply ignore the 0. Minus 0 is not going to make any difference to the value of x. So just ignore minus 0. So you get x square plus y square. So what is x square plus y square? See here, x square, this one, x square plus y square, this one. So OP is equal to square root of x square plus y square. The distance of any point. So supposing P is given by say minus 1, minus 2. Minus 1, minus 2. Minus 1, minus 2. The distance of the point P given by the coordinates minus 1, minus 2 from the origin is, so again OP is equal to square root of x square. So minus 1 the whole square plus y square. Y is minus 2 the whole square. I said instead of x, y, we'll have the coordinates as minus 1, minus 2. So it will be, the formula says x square plus y square. So that means here x and y here. So minus 1 the whole square plus minus 2 the whole square. So that is 1 plus 4, 5, root 5 units. Root 5 units. So distance formula is used to find the length of a line segment in the Cartesian plane or the distance between any two points in the Cartesian plane. And this is an extension of the distance formula. If you want to find the distance of any point from the origin, then it's given by It's an extension of the distance formula. Using this only we get this. It's given by, so here OP is equal to square root of x square plus y square. In general, how do you express the coordinates of a point lying on the x-axis? In general, how do we express the coordinates of a point lying on the x-axis?
X comma 0, ma'am.
X comma 0.
X
Comma 0. Yes, x comma 0. A point lies on the x-axis. So in general, this point is given by the coordinates x comma 0. Okay, now a point lies on the y-axis. In general, we express it as the address of this
0,
point, which, okay, 0 comma y. Any point lying on the y-axis, any point lying on the y-axis is given by the address 0 comma y. Now, supposing I have 3 points A, B, and C. Okay, I have 3 points A, B, and C. And I say that C is equidistant from A and B. What would you conclude? Or you come up to, so you come out with some equation, right? What is that equation? There are 3 points A, B, and C. This point C is equidistant from A and B. Yeah, how do you express this as an equation?
AC is equal to BC, ma'am.
AC is equal to BC. Very good, Tirunesh. Good. So because C is equidistant from A and B, that is the distance. C is equidistant. C is equidistant. So that means C, the distance from C to A is the same as the distance from C to B. C is equidistant. C is equidistant. That means the distance from C to A is the same as the distance from C to B. Okay, but C need not be the midpoint of AB. So see, it's like this. Let me just use this. And now, supposing children, just use this figure. Now, supposing I say N is equidistant from B and A. See it? N is equidistant from B and A. Supposing not in this figure, children. I'm just telling you how to understand the meaning of the term equidistant. Now, supposing we talk about the 3 points N, B, and A. N, B, and A. Now, if we say that N is equidistant from B and A, N is equidistant from B and A, that means the distance NB is equal to the distance NA. But you see that N is not the midpoint of AB or something. The 3 points are not collinear. The 3 points are not collinear. They need not be collinear. Simply because it is equidistant, don't think that N should be the midpoint of AB. It may be, but it need not be. So you can take this example here. So 3 points N, A, and B. NB is equal to NA means N is equidistant from A and B. But we see that N is not the midpoint of AB. In fact, the 3 points A, N, and B, they're not even collinear. They don't lie on the same straight line. We recalled the distance formula, the distance of any point from the origin, and the general coordinates of any point lying on the x-axis, the general coordinates of any point lying on the y-axis, and what is meant by equidistant. What is meant by equidistant? I think we finished all this yesterday. Yeah, I think we have to start with the 11th one. Tell me if I'm right.
Yes, ma'am.
Yes, ma'am.
All right, children. Children, do you want me to recall any of these answers? Just have a look at the questions. Have a look at the questions just in case. Example 1. Finding the distance between 2 points is the direct application of the distance formula. And distance between 2 points, okay, from the origin. So root of x square. You can directly do root of x square plus y square. Here they've used a distance formula. 6 minus 0 the whole square plus minus 6 minus 0 the whole square. 1 mark, you can just use the other formula, root of x square plus y square. So root of 6 square plus minus 6 the whole square. So 36 plus 36. Yesterday I told you under the square root when you have to add two numbers like this, two equal numbers, 36 plus 36. I told you write it as 2 into 36. Root of 36 plus 36. Don't add and write root 72. Don't write this. Write it as 2 into 36. 36 plus 36, which is 2 into 36. So 36 is a perfect square. It comes out as 6 root 2. 2 remains under the square root, so 6 root 2 units. Okay, so here in example 4, we have we have these 2 points A and B. You know the address of A, but the address of B is incomplete. The y coordinate of B is unknown. The y coordinate of B is unknown. A and B are the 2 points. We know the address of A, but address of B, we don't know the y coordinate of B. But we are given that the distance between the 2 points is 10 units. The distance between these 2 points is 10 units. That means we know AB is 10. You should write that first. When you know the distance between 2 points, you must write this one first. So AB is equal to 10. That is the length of the line segment AB is equal to 10 units. AB, the distance between A and B is 10. So AB is 10. So AB square is 100. When you square this on both sides, AB square is 100. And how do we find AB square? Just use the formula without the square root. See here, AB square. You just don't use the square root. That's all it is. AB is square root of this. AB square. It's the same thing, just without the square root. This expression alone. So it is 3. So difference between the x coordinates. You can write 3 minus 11 or 11 minus 3. There will be only 2 x coordinates. We have 2 points. We have 2 points. So there is one x coordinate here. There is one x coordinate here. 2 x coordinates we have. Subtract any order. 3 minus 11, 11 minus 3, both are fine. Square it. Plus, we have 2 y coordinates, minus 1 and y. Subtract any order. But make sure you're subtracting y minus 1. So it will be y plus 1. Y minus 1. So y plus 1, or you can write minus 1 minus y. Minus 1 minus y, the whole square. So AB square, I'll tell you how to expand. When it is minus 1 minus y the whole square, I'll tell you how to expand. Yeah, so AB is 10, AB square is 100, AB square is expressed like this, is equal to 100, is equal to 100. Now, when you have minus y minus 1 the whole square, the thing is which formula to use. Which formula to use? Listen carefully, children. When you have minus y minus 1 the whole square, minus y minus 1 the whole square, which formula to use? You can use a plus b the whole square or a minus b the whole square. When you want to use a minus b the whole square for minus y, I hope you're getting me clearly. I'm talking about minus y minus 1 the whole square. Or minus 1 minus y. Okay. No, what do we get? Y, okay, minus 1 minus y. Yeah. if you write it as -1 minus y the whole square, we are confused as to which formula will work for this, a plus b the whole square or a minus b the whole square. You can use anything. When you treat minus, you can just write it in your book as I'm saying now. If you have written it as -1 minus y the whole square, -1 minus y the whole square. If you treat it as a minus b the whole square, tell me what is a? If you treat it as a minus b the whole square, what is a?
-1.
-1. And then what is b? Minus b is minus y. Minus b is minus y. So what is b? Only y. Do we understand that? When you
Yes,
compare, yeah, when you compare, yes. When you compare -1 minus y the whole square with a minus b the whole square, on comparing, you can see that a is -1. A is -1. Then that minus b is minus y. So that means b is only y. B is only y. So in the formula, in place of a, you must substitute -1. And in place of b, you must substitute y. But if you treat -1 minus y the whole square as a plus b the whole square. Now tell me what is a and what will be a and b if you treat it as a plus b the whole square. -1 minus y.
A is -1, B is -y.
Correct. A will be -1 and b will be minus y. Because you're treating it as a plus b the whole square. But there's minus sign there. So a will be -1 and b will be minus y. So when you're expanding a square plus 2ab plus b square, in place of a and b, you should use these values. That's all it is. Okay, so I said when you read this, the distance between the 2 points is 10 units. You must immediately write AB is 10. So AB square is 100. AB square, this is the formula, is equal to 100. Instead of AB square, we write this is equal to 100. So we solve and find the values of y. So this was about equidistant. P is equidistant, so PA is equal to PB. So if PA is equal to PB, PA square is equal to PB square. This is how we express PA square, and this is how we express PB square using the distance formula. So when it is PA square, use the points, use the address P, use the address of P and A. P and A. And then difference between x coordinates whole square plus difference between y coordinates whole square. All right. See, write this, that's it. If you can write PA is equal to PB, so PA square is equal to PB square, then you're going to substitute. For this, you're going to substitute this by the formula. And for this, you're going to write this by the formula. So here you got an equation. So now this is completely your algebraic skills. Solve and find the values of K. So find the relation between X and Y. P is equidistant from A and B. So same thing. P is equidistant from A and B. So PA is equal to PB. Write the condition from the given information. So PA is equal to PB because P is equidistant from A and B. So PA is equal to PB. PA square is equal to PB square. PA square by the distance formula is this one. And PB square by the distance formula is this one. So this is PA square is equal to PB square. Now after this, it's algebraic. So you'll have to read this question and write PA is equal to PB. So PA square is equal to PB square. If you can write this, then you know the distance formula. So instead of PA square, the formula here. and PB square. Using the formula, we replace x1, x2, all that. We replace according to P and B, the coordinates of P and B, and get this. That's completely algebraic. And here you'll have to find the relation between x and y. So I said leave the answer like this. X plus y minus 3 is equal to 0. Write it as a linear equation in the standard form. But again, if it's an objective question, now you should select the correct option. Now don't say you did not find x plus y minus 3, so you did not know how to pick the answer. Maybe if you have to choose one of the 4 options, then it can be in any form. It can be like y is equal to 3x. It can be in any form. If it is a subjective question, then the preference is to leave the relation in the standard form. Because it's a linear equation, just leave it in the standard form. You can either leave it like x plus y is equal to 3 or x plus y minus 3 is equal to 0. Okay. So here also distance is phi is given. Distance between what and what? There is only one point A. There's only one point A. So we assume the other point which is on the x-axis to be x comma 0. There's another point on the x-axis. So in general, x comma 0. So this PA is 5 units. That means PA square is 25, squaring on both the sides. Now use the formula and replace PA square with this is equal to 25. Solve. The y-axis. If it's on the y-axis, 0, comma y. If it's on the y-axis, 0, comma y. Here it is, find the point on the x-axis which is equidistant from this and this. So we'll call this A, we'll call this A, we'll call this B, and there's a point on the x-axis. So let that be P x comma 0 because it's on the x-axis. So x comma 0, P x comma 0. So we have 3 points. We have this point P x comma 0 because it lies on the x-axis, and we have this A and B. What is the information we have? Find the point on the x-axis which is equidistant from A and B. So this point P is equidistant from A and B. That means PA is equal to PB. Is given, which is equidistant. So PA is equal to PB. That means PA square is equal to PB square. Distance formula, distance formula. Algebraic work. This is. You get the value for x. X is 1, which means the point is 1, comma 0. Now this was x-axis. This was x-axis. Find a point on the x-axis. Now here it is find a point on the y-axis. Y-axis. So let that point P be 0, comma y because on y-axis P 0, comma y. This is A. This is B. The point. Let the point on the y-axis be 0, comma y. This is A. This is B. What is the information given? This point on the y-axis, that is P, is equidistant from A and B. That means PA is equal to PB. PA square is equal to PB square. If you can write this and if you know the distance formula, that's all. It's very simple. Come to the 11th one. Find the coordinates of the point. Find the coordinates of the point equidistant from 3 given points. So there is one point, and that one point is equidistant from 3 points A, B, and C. There is one point. It's not given that it lies on the x-axis or y-axis. It lies somewhere. So let the coordinates be given by x comma y, not x comma 0 or 0 comma y, because it's not given that it lies on the x-axis or y-axis. General point x comma y. So let that point P be given by the coordinates x comma y. Now that point P is equidistant from A, B, and C. That means PA is equal to PB is equal to PC. Children, don't work the way you see it on the screen. Follow my instructions. So this is the condition because that point P is equidistant from A, B, and C, which means PA is equal to PB is equal to PC. Again, on squaring, you get PA. If PA is equal to PB is equal to PC, then PA square is equal to PB square is equal to PC squared. Now, children, all of you find. Now from this you can work 3 cases, but it's enough to work 2. Now you can take up this equation PA square is equal to PB square and work it, or you can take up the equation PB square is equal to PB square and work that, or you can take up the equation PA square and PC square. PA square is equal to PC square. So you from this we can get 3 different equations. From this you can get 3 different equations. But it's enough if we have 2. So choose anything. So here they've taken up they've equated PA square and PB square and PB square and PC square. You can also do with PA square and PC square. See here, like this is equal to this is equal to this. So PA square is equal to PB square. PB square is equal to PC square. So let's work this. PA square is equal to PB square. How do you find PA square, children? P is x comma y. So x minus 5 the whole square plus y minus 1 the whole square is PA square. So now you're comfortable, children. So you can find PB square. Work this and tell me the equation, please. Take up this condition PA square is equal to PB square. Work this and tell me the equation you're getting. Then take up this equation PB square is equal to PC squared. Work this and tell. You will get one linear equation in x and y for this, another linear equation in x and y for this. Please work this one first. These are different. Work this and then work this. Yes, get started. Write the question, get started. Muttuvel, are you there?
Yes, ma'am.
Yes, Muttuvel, tell me the equation you're working with.
Ma'am, I have not completed the ma'am.
No issues. You've started working something. No, please read what's in your book.
Yes, ma'am. X square minus 10 y square minus 1 equal to x square plus 9.
1 minute, darling. Please. Slowly. First, see, have you written PA square is equal to PB square?
Yes, ma'am.
Okay, below that, what have you written?
How
How did you expand PA square?
Ma'am, x minus 5 square y minus 1 square equal to x plus 3 square plus y plus 7 square.
Okay, now after that, what have you written?
X square minus 10.
X square minus?
X square minus 10 y square minus 1 equal to x square plus 9 plus y square plus 1.
No, Muttuvel. How do you expand A minus B the whole square? Recall the formula from 9th standard.
Okay, ma'am.
No, tell me. We'll do it together now. What is A minus B the whole square?
A square minus 2ab plus b square.
Okay, now according to your answer, you for x minus 5 the whole square, you said something like x square minus 10 or something. What have you written? X square minus 10, is it?
Yes, ma'am.
So see, Muttuvel, you're careless there. You expanded correctly. No, you said a square minus 2ab plus b square. So what is a square then? In x minus 5 the whole square, what is a square? Yes.
5x square.
No. 1 minute. X minus 5 the whole square, right? So that is like a minus b the whole square. So what is a there? X, right?
Yes, ma'am.
And what is b?
Y.
No. See here, this one. This is a minus b the whole square. All right. A minus b the whole square. So a is x. A is x and b is y 5. Now what will be a square? X square. Then minus 2ab minus 2 into x into 5 plus b square plus 5 the whole square. Now tell me for y minus 1 the whole square, Muttuvel.
Ma'am, y square minus 2 into y minus 1 square.
2 into 2ab 2 into y into 1 2ab 2 into y into 1
Okay.
plus 1 the whole square b square. You must get 3 terms when you expand. Similarly, when you expand a plus b the whole square, it is a square. You should write one term a square, then the 2ab term plus 2ab and then plus b square. Otherwise, you will not get this equation which you see on the screen.
Okay, ma'am.
Yeah, okay. Try to do it now.
Ma'am,
Yes.
I shared my work in the group. Please check it.
Oh. Yes, Srinivasan, your answer is right. Children, so did you manage to get the equation for PA square equal to PB square? What is it you got?
Ma'am, I got x is equal to 2 minus y, ma'am.
X is equal to 2 minus y. X is equal to 2 minus y does not look correct.
1 minute, ma'am.
Some blunder with the signs.
Ma'am, x plus y equal to 2.
Yes, x plus y is equal to my. All of us know it is on the screen. I just want to know that if the same is in your book, that's all it is. So, yeah, so it's not funny. My question is not funny. The equations and the
sorry, ma'am.
answers on the
2
screen. I'm
minus
just
x.
checking if it is in your book. Yes, Shakti?
Ma'am, I got 2 minus x is equal to y, ma'am.
2 minus x. 2 minus x is equal to y. That also does not look correct.
Ma'am, I got that minus x minus y is equal to minus 2, ma'am.
No, you should get minus x minus y is equal to plus 2. Just see that. Check that. You must get minus x minus y is equal to plus 2.
Yes, ma'am. Sorry, ma'am.
Okay, okay. No, thank you. You helped me
I
actually.
didn't check that equal.
Yeah, okay, yeah. Minus x minus y is equal to plus 2 you must get. Okay. Children, please expand carefully. A minus b the whole square, a plus b the whole square. Don't forget the middle term 2ab. When you expand, you will get 3 terms. When you expand x minus 5 the whole square, you will get 3 terms. All right, so you shouldn't have any difficulty in arriving at this equation, children. Then after getting this, then work PB square equals PC square. So you see it here. This is PB square equals PC square. Work this one and you'll get the other equation. Yeah, so you don't get a linear equation x and y. Do we get? Yes, here it is. So this is the other equation. This is the equation from the first condition. This is the equation from the second condition. 5x plus 3y is equal to minus 2. And you know very well that you can solve these two equations because you've learned linear equations in school as well as here. So you know you can solve these two linear equations and find the values of x and y. X is 2, y is minus 4.
Ma'am?
Yes.
Ma'am, I have one doubt, ma'am.
Yes, please ask.
Ma'am, I can't understand that expanding, ma'am, that x square plus y square minus 10x minus 2.
On the screen, is it?
Yes, ma'am.
No, here they have skipped some steps. We know that. No, I'll tell you what it is. You see your book if you have it.
Okay, ma'am.
Yeah. You just see your book if you have it. Because here they would have probably simplified and transposed and all that. So you look into your book. I'll tell you something. Do you have for this one? Do you? No, 1 minute. Was it Priyadarshini?
Yes, ma'am.
Okay, Priyadarshini, did you get this equation x plus y is equal to minus 2?
No, ma'am.
Okay. Fine, Priyadarshini. So here you will get x squared. Did you get x squared? Okay, read out from your book, Priyadarshini.
Ma'am, x square minus 10x plus y square.
How y squared plus 25, right?
No, ma'am, by factorizing.
Where do you factorize, ma? No, see, have you written this step? Have you written this? X minus 5 the whole square plus y minus 1 the whole square is equal to x plus 3 the whole square plus y plus 7 the whole square. Do you have this one in your book?
Yes, ma'am.
Okay, now how do you expand this? I said work only with this one first. PA square is equal to PB square. What do you get? What is x minus 5 the whole square? Yes, Priyadarshini, tell me.
Yes, ma'am. Sorry, ma'am. I'm thinking x minus 5, ma'am.
No, here they have simplified and given 26. You will get 25 from here and plus 1 from here. They've written 26 straight away here. No, Priyadarshini, what was your doubt? I don't know. Please tell me that. I want to know that. What was the doubt? What was the confusion?
No, ma'am, I can't understand that factorization.
Which factorization, ma? We are not factorizing here. We are expanding.
Ma'am, the second step, ma'am, x square plus y square minus 10x
Who
minus
asked,
2y.
who asked you to see this one, darling? I told you, right? I told you just write this and do proceed with the, working by yourself. Don't see anything here. So how did you, that's what I'm asking you. What did you write next? After this, did you write x square minus 10x plus 25? Okay, class. So after this, PA square is equal to PB square. So this is what is PA square is equal to PB square. Now this will be x square minus 10x plus 25 plus y square minus 2y plus 1 is equal to x square plus 6x plus 9 plus y square plus 14x plus 49. Now this one, bring all the terms to x square and y square on either side will get cancelled. Bring all the terms to one side and you will get this equation x plus y is equal to minus 2. We are not factorizing at all here. We are expanding. We are using the formula a minus b the whole square, a plus b the whole square and expanding it. We are not factorizing. Then we take up this equation pb square is equal to pc square, which is this one. pb square is equal to pc square is this one. So again we expand this, expand this and expand this. You will get 3 terms, 6 terms here, 3 terms, 6 terms here. You'll have 6 terms in the LHS and 6 terms in the RHS. X square, y square on either side will get cancelled. Bring all the terms to one side, you will get the other equation x and y. On solving the two equations, you will get x is 2 and y is minus 4. No, this is simple for you. It really does not. Yes, Shakti.
After first step, I got x is equal to minus y minus 2, ma'am.
After the first step, huh?
Yes, ma'am.
Which first step?
I mean, expanding the PA square is equal to PB square, ma'am.
Okay.
And after that, I got x is equal to minus y minus 2, ma'am. So we can substitute in the x terms, and by that we can get the y value, ma'am. We can do like that, ma'am.
You can use any method. Yeah, you can use the substitution method. You're saying the substitution method? Are you talking about the substitution method?
Yes, ma'am.
Yeah. You can solve anyways. Yes. Priyadarshini, get back. What's your doubt?
Ma'am, now it's clear, ma'am.
You tried to follow what is here. Is it on the screen? Okay, fine. You got it? Did you get the two equations?
Yes, ma'am.
All right. Okay, let's also understand this one, which is called the section formula, so that we can take up questions based on both simultaneously. It's the same chapter, coordinate geometry. The first part of coordinate geometry is distance formula and problems related to distance formula. This is the second part of the chapter. So here on the screen, you see the derivation of the section formula. And you have problems based on this. Okay, now what is section formula? When to use section formula? Now, in the Cartesian plane, while using the distance formula, we saw that we have 2 points in the Cartesian plane. So like that, say we have 2 points A and B here in the Cartesian plane given by the address x1, y1, x2, y2. X-axis, y-axis, we have 2 points A and B given by the address x1, y1, x2, y2. Now, let's say there's a point P. There's a point P that lies on the join of the points A and B. That is, we have point A and we have point B. P lies on the join of A and B. That is, P lies on the line segment AB. P lies on the line segment AB. And let's say the address of P is x, y. Now, definitely P will divide the line segment AB in some ratio. Since P lies on AB, it will divide the line segment AB in some ratio. So let that ratio be called m/n. Let that ratio be called m/n. Let me repeat the whole thing. Cartesian plane, 2 points A and B. A, x1, y1, B, x2, y2. When you connect the 2 points A and B, you get the line segment AB. P is a point that lies on the line segment AB. And let's say the address of P is x, y. The address of P is x, y. Now, since P lies on the line segment AB, it will divide the line segment AB in some ratio. It will divide the line segment AB in some ratio. So let the ratio be m/n, that is AP by PB. AP by PB. Let that ratio be m/n. M is to n. AP, PB. See, AP. If P divides AB, then one piece will be AP. The other piece will be PB. So let the ratio AP is to PB be called m/n. Okay, with so much, what are we trying to find? Now we are trying to find the section formula helps you to find the address of the point P that divides the line segment AB in the ratio m/n. Don't worry if you didn't understand. Section form, the direct application of the section formula is to find the coordinates of this point P that divides the line segment AB in the ratio m:n. So we are going to find the formula that will help us find the x coordinate of P and the y coordinate of P. See, when I've just started, things will sound vague. When I complete and when I repeat, it should be clear. At that point, if it is not clear, please ask me. So section formula will help us to find the x coordinate of P and the y coordinate of P. And what is P? P is a point that lies on the line segment AB. So since it lies on the line segment AB, it will be dividing the line segment AB in some ratio. And here we call the ratio m:n. Now, what are the requirements? To use a section formula, what is that you need to know? To use a section formula, you need to know the address of A. Like it should be something like 3, 5. You should know the address of A. You must know the address of B, the complete address of B. You must know the x coordinate of B and the y coordinate of B. And then you should know the ratio m:n. So something like 2:3 or 5:2. See, we are discussing the various components here. We have 2 points, A and B. You need to know the address of A and B. And then there is this point P, whose address we don't know. That is what we're trying to find using the section formula. We're trying to find the address of this point P. We're trying to find the x coordinate of P and y coordinate of P. That means others we should know. We're trying to find x and y. The rest of the information should be given to us. We should be given the address of A. We should be given the address of B and also the ratio in which P divides AB. So you must know the ratio, something like 4:1 or 5:2. You should know the ratio. You must know the address of A, you must know the address of B, and you must know the ratio AP is to PB. If you know all this, then by using the section formula, you can find the x coordinate of P and the y coordinate of P. That is, you can find the coordinates of the point P using the section formula. See, now when we say volume is equal to LBH for a cuboid, volume is equal to LBH. That means when you're given the length, breadth and height of the cuboid, you can find its volume using LBH. That's a direct application of the formula. When you have a cuboid and you know the length, breadth and the height of the cuboid, volume can be found using the formula Lm to B into H. But that's not the only use of this formula. Supposing you're given the volume of the cuboid and the length and the breadth of the cuboid, this formula can be used to find the height of the cuboid. So like that, section formula has other uses. This is the direct application. The direct use of the section formula is what we are discussing now. Like I told you, volume is LBH. Supposing you're given the volume of the cuboid, you're given the length of the cuboid, you're given the breadth of the cuboid. So you can use the same formula, volume is equal to LBH. You can substitute the values of volume, length and breadth and find height. So you can use the volume formula for different other things. Directly, this is used to find volume, but you can also use it to find length, breadth and height. Similarly, section formula was was derived or was found to find the coordinates of the point of division. P is called the point of division. P is called the point of division. So section formula is used to find the coordinates of the point of division. But later you will see that you can use it for other things also. What other things we'll see when we take up problems. Okay, so A given by the coordinates x1, y1 B given by the coordinates x2, y2. P lies on the line segment AB. Let's say the coordinates of the point P is x, y. The ratio AP is to PB is M is to N. Because P lies on AB, it divides AB in a specific ratio. Let it be M is to N. Now, section formula is used to find the coordinates of the point P. Given the coordinates of A, B, and the ratio. Given the coordinates of A, B, and the ratio, you can use a section formula to find the coordinates of the point P. This will not be given to you. This will not be given. You will be given the ratio. You will be given the coordinates of A and B. So AB you know, and you know the ratio. If you know this, you can use a section formula to find the x coordinate of P and y coordinate of P. That is the coordinates of P. So let's see how the formula is derived. You see here section formula. The coordinates of the point P, x, y, which divides the line segment joining A, x1, y1, B, x2, y2 internally. Internally meaning P lies on the join of AB. There is also called something called external division, where P will lie on AB produced. When you produce a line segment AB, we don't have that in our syllabus. So I'll just tell you, since we came across this word internally, let me tell you what externally is. So AB, this is AB. When you produce a line segment AB, say to a point C, and if P lies on AB produced, then that means P divides AB externally in the ratio AP is to BP. Now don't worry about it if you didn't understand. External ratio will be AP is to BP. We don't have that in our syllabus. Internally meaning P lies on the join of A and B. It lies on the line segment AB and not on AB produced. If P lies on AB produced, then it is a case of external division. P lies on AB, internal division. Internally in the ratio M is to N are given by, see the coordinates of P. So read it like this. The coordinates of the point P, x, y are given by the coordinates of the point P. The coordinates of the point P, x, y are given by x is equal to, that is the x coordinate of P is equal to mx2 plus nx1 by m plus n. And the y coordinate of P is equal to m. You can find the coordinates separately. If you want to find only the x coordinate, you can use this and find only the x coordinate of P. If you want to find only the y coordinate, you can use this and find only the y coordinate of P. If you want both, then you'll have to use both. The y coordinate of P is given by my2 plus ny1 by m plus n. So you can see to find the x coordinate of P, x1, x2 and the ratio m is to n is used. x1, x2 and the ratio m is to n is used. To find the coordinates of y, sorry, to find the y coordinate of P, to find the y coordinate of P, y1, y2 and the ratio m is to n is used. See here m, n, mn, y1 and y2. So for finding the y coordinate of P, we use only the y coordinates of A and B. To find the y coordinate of P, we use only the y coordinates of A and B and the ratio m is to n. To find the x coordinate of P, to find the x coordinate of P, we use only the x coordinates of A and B, x1 and x2, along with the ratio m and n, m is to n, not m and n, sorry, m is to n. I'm just pausing for some time. Look at the screen and read it for yourself. Just observe the figure. I'll tell you the construction and all that. Just read and observe the figure. Okay, let's resume. So we have 2 points A and B given by the address x1, y1, x2, y2 in the Cartesian plane. AB is the line segment joining the 2 points A and B. P lies on the line segment AB, dividing the line segment AB in the ratio m:n. Now we want to derive the section formula using which we can find the x coordinate of P and the y coordinate of P in terms of x1, x2, m and n for the x coordinate, in terms of y1, y2, m and n for the y coordinate. When you derive, you will see that the x coordinate of P is made up of x1, x2, m and n. And the y coordinate of P is made up of y1, y2, m and n. So let's see how to derive it. So here we use the concept of similar triangles. We haven't still, learned this chapter here in the classroom. But anyways, I'll just tell you what it is. We'll see it in detail when we take up that chapter. Just to make you understand the proof, I'll tell you. Whatever is needed for the proof, I'll tell you. Fine. So now construction, draw AL perpendicular to the x-axis. That is XO, X dash. XO, X dash or the x-axis. From A, draw AL perpendicular to the x-axis. From P, see from these 3 points A, P and B. From these 3 points A, P and B. So from A, draw AL perpendicular to the x-axis. From P, draw PN perpendicular to the x-axis. And from B, draw BM perpendicular to the x-axis. So from A, P and B, from these 3 points, we draw perpendiculars to the x-axis. After that, draw AR perpendicular to PN. Draw PS perpendicular to BM. That's how we get this figure. First A and B, join it. Take a point P, x, y on it. From A, P and B, draw AL, PN and BM perpendicular to the x-axis. From A, draw AR perpendicular to PN. From P, draw PS perpendicular to BM. Like this, we get 2 triangles, ARP and PSB. ARP and PSB. We get two triangles, ARP and PSB. Now these two triangles are similar. These two triangles are similar. Triangle ARP is similar to triangle PSB. Now children, just take it like this for now because we have not learned the chapter. Now how to prove that they are similar? We'll not take up that now. Now just take it from me that these two triangles are similar. These two triangles are similar for some reason. Now once the triangles are similar, their corresponding sides will be proportional. You don't have to write why these two triangles are similar in this proof. So these two triangles are similar. Once they are similar, their corresponding sides are proportional. See, a triangle ARP is similar to PSB. So AR by PS will be equal to RP by SB will be equal to AP by PB. That is AR of this triangle by PS of this triangle will be equal to RP of this triangle by SB of this triangle will be equal to AP of this triangle by PB of this triangle. When you write ARP similar to PSB. So ARPS from the order ARP PSB. AR by PS is equal to, you should take one side from the first triangle, the other side from the second triangle. So AR by PS is equal to RP by SB is equal to AP by APs of this triangle by PB. That's it. We just proved that the triangle is similar. Or we use the proportionality. Like to derive the distance formula, we use Pythagoras theorem. To derive the distance formula, we used Pythagoras theorem. To derive the section formula, we use the concept of similar triangles. We show that these two triangles are similar. In similar triangles, corresponding sides are proportional. Proportional meaning ratio. Now, we say that A by B is equal to C by D is a proportion. What is the proportion? What is the proportion? Equality of two.
A is proportional to C is to D.
Yeah, when two ratios are equal, they are said to be in proportion. When two or more ratios are equal, they are said to be in proportion. So A by B is equal to C by D is a proportion. A by B equal to C by D is equal to E by F. We have ratios A by B, C by D, E by F. We have these three ratios and they're all equal. A by B is equal to C by D is equal to E by F. So when equality of ratios, when ratios are equal, they are said to be in proportion. So we derive the section formula by using the concept of similar triangles. We have two triangles here. They are similar. That is triangle ARP is similar to PSB. Once they are similar, their corresponding sides are proportional. Proportional meaning ratios are equal. Ratio of the sides. AR of this triangle by PS of this triangle is a ratio. AR by PS is a ratio. RP by SB is a ratio. AP by PB is a ratio. These three ratios are equal because the triangles are similar. Then we substitute the values for each of the portions in that ratio and hence derive the section formula. So now let's proceed with the proof. Now to substitute in the proportion, no, I was just trying to tell you why we need to find. Now look at this, children. When we say ARP is similar to PSB, see here, AR by PS is equal to RP by SB is equal to AP by PB. It's enough if you write this. these two triangles are similar, so their sides are proportional. See, like this. Now, to proceed with this, we need to know what AP is, PB, AR, PS, PR, and BS. That preparation is what we do here. That preparation is what we are doing here. What is AR? What is AR? What is PS? What is PR? What is BS? Because only if you know that you can substitute in this proportion. See it? We need to substitute for AP, PB, AR, PS, PR, and BS. Like how when we had to use Pythagoras theorem, AB square is equal to AC square plus BC square. When we derived the distance formula, we found AC. We found AC and BC, and then we substituted in the theorem, the Pythagoras theorem. Here we are using this proportion. So to use this proportion, we need to find what to substitute for AB, PB, AR, PS, PR, and BS. That preparation. Once you find that, you just substitute and derive the formula. So that pre-work. To use the proportion, this is the pre-work. Shall I proceed, children?
Ma'am, 1
1
Yeah.
minute, ma'am.
A minute for you're writing something?
No, ma'am, I'm reading the
No, ma'am.
expense.
Reading this, ma'am.
Which one? Which one?
Ma'am, this
The similar triangle.
AL is perpendicular to AX.
Oh, yeah. That alone you read. Yes. Yeah.
Yes, ma'am.
Yes.
Yeah. Now, children. So when these two triangles are similar, we said AR by PS. AR by PS. So let's find AR and CS. So we find AR and PS. AR by PS is equal to RP by SB. That's why we find RP and SB here. Is equal to AP by PB. AP by PB we already know. AP is M and PB is N. AP by PB is M by N. That we already know. Like we used Pythagoras theorem to derive, the distance formula, we use the concept of similar triangles. So we use the proportion. We use a proportion here to derive the section formula. These are the two triangles in the figure. And the proportion goes like this. AR by PS is equal to RP by SB is equal to AP by PB. So we are trying to find AR, RP, PS, and SB. Okay. Now, what is AR, children? We know AP and we know AP by PB, M by N. We know AP by PB is M by N. The rest we have to find. AR by PS. So let's find AR. AR is equal to LN, children. Is AR equal to LN?
Ma'am.
Yes.
Yes, ma'am.
Yes, ma'am.
Is LN equal to ON minus OL?
Yes,
Ma'am.
Yes, ma'am.
ON minus OL. Now, what is ON?
Ma'am, root of X square plus Y square. Ma'am.
What is ON?
X. Ma'am.
X. ON is X.
Yes, ma'am.
Yes, I understand what you meant, Shakti. Okay, root X square. You're trying to say that the distance of any point from the origin is root of X square plus Y square. No, I didn't. I was not asking that. The distance. Now here we have P is given by X comma Y. So if the x coordinate, this is the x coordinate of P, which will be marked here. Yesterday we understood, no, while deriving the distance formula. If this is x, it's marked x here. So that means ON is x units.
Yes, ma'am.
If this is x here, that means on the x-axis, it's marked x here, x. So that means ON is x units. And what about OL? What about OL?
X1 units, ma'am.
X1.
X1, because see here x1, this point is given by x1 comma y1. If this is x1, this is x1. That means from here to here is x1. So we have to find AR, which is the side of this triangle, AR. That's nothing but LN, which is ON minus OL, x minus x1. So
Minus
AR,
X1, ma'am.
yeah, x minus x1. Now let's find PS. What is PS equal to?
NM.
NM. And NM can be found using? How do we?
LM minus LN.
No, always start with the origin.
X2 minus X, ma'am.
No, tell me using line segments first.
OM
Please start with the origin. O,
OM minus ON, ma'am.
OM minus
ON, ma'am.
OM minus ON. OM, always start from the origin because these lengths are from the origin. OM minus ON will be NM or PS. So how much is OM? What is OM?
X2.
X2. What about ON?
X.
X.
X, ma'am.
X. So MN or NM will be from here to here X2 minus X. Is that correct?
Yes, ma'am.
Only few of us are participating. See, I'm not going ahead with those who are answering. I'm open to anybody's doubts. You should participate, children. Okay, now let's try to find PR and BS. Let's try to find PR and BS. We found AR and PS. Now we're trying to find PR and BS. Okay, so what is PR? How do we find PR? Tell me PR.
PN minus RN, ma'am.
Perfect. PN minus RN. How much is PN?
Y minus Y.
Y, because if this is Y,
Y minus.
how do you mark this point x comma y? From here to here is x, and this y, this is y, this one is y. On the y-axis here it is y. This is y. This one is y. This one is y. So Pn is y. Pn is y. And how do you find Rn? Rn is nothing but Al.
Y.
No, Rn. Rn is nothing but Al. Al. How much is Al?
Y1.
Y1. Al is Y1.
Y1.
Because, yeah, because X1, Y1. So this is X1. From here to here, this is X1. This is X1. And Y1, this is Y1, which means this is Y1. This is Y1. This is Y1. This is Y1 and this is X1. It's marked X1 here. It's marked Y1 here. That's why this point is X1 comma Y1. So this one is Y1. PR is equal to PN, that is Y minus RN. RN is nothing but AL, which is Y1. So Y minus Y1. PR is equal to Y minus Y1. Now tell me what is BS?
BM minus SM.
Y minus Y.
BM minus SM. What is SM equal
Yes,
to?
ma'am.
PN.
SM equal to?
PN.
Pn.
Pn, ma'am, which is y.
Yeah.
y2 minus y.
Yeah. What is the height of Bm? Bm.
It is y2, ma'am.
Y2.
ma'am.
And Pn.
y2 minus y.
Y2 minus y, because it is Bm, which is y2, minus Sm. Sm is nothing but Pn, which is y. So y2 minus y. AP by PB we know as m is to n. So that's what you see here. Now I'll show you the entire slide. Read this. Get this part clear. What we discuss is here. What we discuss is here. You can just have a look at this. Or maybe let me finish the proof, children. So now that we found this, let me finish the proof. So first is you need to take up the points A, B, join A, B, then this point P, X, comma, Y. Then these three perpendiculars you need to drop. And then these two perpendiculars. Like this, we get two triangles. These two triangles are similar. If they are similar, then that proportion will happen. AR by PS is equal to RP by SB is equal to AP by PB. Now we are going to use this proportion to derive the section formula. To substitute the values for the line segments in the proportion, we do that work, pre-work here. Now we substitute. See the next slide. Now we substitute. Children, this is just substitution, children. You will understand this. So this is the proportion. Substitute AP by PB is m by n. AR we have found there, x1 minus x1. PS we have found x2 minus x. All this we have found. Now equate these two to find x and equate this with this to find y. Equate m by n to this one to find x, to find the value of x, and equate m by n to this one to find the value of y. So let's equate these two. Let's equate these two. M by n is equal to x minus x1 by x2 minus x. Cross multiply. So this is what you get on cross multiplying. This is what you get on cross multiplying. This is what you get on cross multiplying. Now it's important. We are trying to solve for x. So gather the x terms on one side. Gather all the x terms on one side. So you should do that work. Gather the x terms on one side. Don't follow whatever is done here. I'm telling you, there are two terms with x. So you can take this mx here. So you will get mx plus nx is equal to mx2. And this will come here plus nx1. Children, there are four terms. Children, there are four terms. There are four terms. You gather the two x terms. This one has x and this one has x. This is x2 and x1. Have them together. Have the x terms mx plus nx on one side. And take out x common. Take out x common. So you will get m plus n in the bracket. So x is equal to mx2 plus nx1 by m plus n. Take the x terms on one side. Take this mx to this side. So you'll get mx plus nx. Bring this here. Then since you're solving for x, take out x common. And you will get mx2. X is equal to mx2 plus nx1 by m plus n. Similarly, on equating this with this, equate this with this. So see here, equating these two, cross multiply, cross multiply. There is this term with y and there is this term with y. These have y2 and y1. These are the two terms with y. Take them to one side. My plus ny. My plus ny. Take out y common. So on doing that, we get y is equal to my2 plus ny1 by m plus n. Yes, I want all of you to work this now in the class. So the coordinates, so we found x and y separately. Now when you put them together, they make the coordinates of the point P. So the coordinates of the point P are given by mx2 plus nx1 by m plus n, comma my2 plus ny1 by m plus n. Because I believe once you do this in the class, work this in the class, you can remember better, you can understand better. Oh my God, sorry.
Can you move a little bit up?
Oh, yes, sorry. Yeah.
Ma'am, if triangles are similar it means they are congruent, ma'am.
Congruent triangles are similar, but all similar triangles need not be congruent.
Okay, ma'am.
Class, use the emoji. Raise your hands. Where are the others? Shreya, are you in the class? Shivani? Sudarshan? Okay. Akshay Ram? Nivedita? Okay, Nivedita? Yeah. Akshay Ram? Okay, so Akshay Ram, Nivedita, Sudarshan, Shivani, Ashwin, Shreya, Manasa, Shakti, Rakshan, Hariharan, Parkavi, Nafi, Balaharish, Arnav, Priyadashni, Lakshita. Oh, Lakshita, you're in, okay. Priya, Muttuvel, Reshmi, Tirunesh, Srinivasan. All right, children. Let's continue.
Ma'am, similar triangles are similar in what way, ma'am?
So when you have a picture, say now you have, say, you have a triangle with
And the shape will be ma'am, but their dimensions will be different.
big or small. Yes, they'll be proportionately bigger or smaller. So say you have a triangle with sides 3, 4, and 5 centimeters. We have a triangle with sides 3, 4, and 5 centimeters. There's another triangle with sides 9, 12, and 15 centimeters. It's bigger, right? 3, 4, 5. We have a triangle with sides 3, 4, and 5 centimeters. There's another triangle with sides 3 into 3, 9, 4 into 3, 12, 5 into 3, 15. So you see that there's another triangle whose each side is 3 times the sides of the original triangle, the first triangle. So we say that the second triangle is similar to the first one, or the first triangle is similar to the second one, because the second triangle is an enlarged version of the first triangle, or the first triangle is a diminished version of the second triangle. You will observe that in these two triangles, their angles will measure the same. It's just that it's proportionately big or small. The angles are not altered. The angles will not be tripled. Just because the sides are tripled, the angles will not be tripled. You will see that the angles are the same. If you construct a triangle if you construct a triangle with sides 3, 4, and 5 centimeters and construct another triangle with sides 9, 12, and 15 centimeters, you will see that both the triangles will have the same angle measures. They'll have the same, exactly the same angle measures. It's just that one is bigger or smaller. Proportionately bigger or smaller. That is, each side is enlarged 3 times or diminished by 3 times, depending, you're comparing from which triangle to which triangle. So
Okay,
this one is in simple words about similar triangles. So you can take your photograph. You can make a stamp size photo of yours. You can make a passport size photo. So these two photographs, your image there in the photograph will be similar. So in a stamp size, your eye, your nose, your features are proportionately small. In the passport size photo, your features are proportionately bigger. You can compare your stamp size photo and your passport size photo. I'm talking about the image in it. The images will be similar. The images will be similar because in the stamp size, your features are proportionately smaller when compared to the passport size photograph.
yes, ma'am.
Yeah.
Yes, ma'am.
All right, children. Yes. Finish this one, children, this page.
No, ma'am.
Yes, ma'am.
Okay. I'll just get back, children. Please write. Cross multiply. These two terms have x. Gather, there are 4 terms. Take the 2 x terms to one side. So this would be mx2 plus nx1 is equal to mx plus nx. So when you take x common, you can find x. Finished, children?
No, ma'am.
Okay. Yeah, I'll wait here. I want you to do it now so that it is, very well understood. Any questions? Get it clarified now?
Completed.
Yeah. Let's apply it in a situation so we understand better. See here. Find the coordinates of the point which divides the line segment joining the points A and B. So we have A given by 4, -3, B given by 9, 7. So we have these 2 points in the Cartesian plane. When you join these 2 points, you get the line segment AB. Now you should find the coordinates of the point which divides the line segment AB, which divides the line segment AB in this ratio 3:2. Find the coordinates of the point. So let that point be P, given by the address x comma y. No, you can call it anything. You can call it D, any letter other than A and B. You can call it C. So find the coordinates of the point. So we need to find the coordinates of a point. So let that point be called P and let the address of that point be x comma y. Now this point P divides the line segment AB in the ratio 3:2. All of you draw a line segment. Draw a line segment, children. All of you draw a line segment. One end write A 4, -3. The other end you write B 9, 7. Do that. Take up a line segment. One end write A 4, -3. The other end write B 9, 7. And on this line segment, mark a point P. And the ratio AP is to BP is 3:2. Ratio is 3:2. That is from A to P, it is 3 parts. From P to B, it is 2 parts. Now remember, this is x1, this is y1. This is x1, this is the A, the coordinates of A make x1 and y1. The coordinates of B make x2 and y2. x1, y1, x2, y2. A makes x1, y1. B, x2, y2. Now find the x coordinate of P, children. X is equal to, what is x equal to? mx2 plus nx1 by m plus n. X is equal to, you can write x coordinate of P is equal to, x coordinate of P is equal to, P is the point, right, on the line segment AB. Right, x coordinate of P is equal to, I'm not showing you the answer. I want you to get it by yourself. X coordinate of P is equal to, write the formula, mx2 plus nx1 by m plus n. Substitute the values and get that number for x coordinate of P. Then write y coordinate of P is equal to, y coordinate of P is equal to my2 plus ny1 by m plus n. Substitute the values. M is 3, n is 2. Find out and tell me. You should work the x coordinate and y coordinate separately, children. X coordinate of P, y coordinate of P separately.
Ma'am, x is equal to 7.
X is equal to 7. Okay, and what about y? Tirunesh, find y.
Ma'am, y equal to 3, ma'am.
Okay, x is 7, y is 3. Now class, tell me which is x1. What's the value of x1, children?
4.
4, ma'am.
4.
4.
Now listen to my question carefully. What's the value of x2?
9.
9, ma'am.
9. What is y1?
Minus 3.
Negative 3.
Minus 3.
Minus 3. And y2?
7.
7.
7.
And the ratio m is to n. M is
3.
3.
3. N?
2.
2.
2. Okay. Now we are trying to find. Now what do we call that point that divides AB internally? P.
P.
Yeah, and what are we trying to find? We are trying to see nowhere we have the address of P. We know the coordinates of A. We know the coordinates of B. There is a point that lies. There is a point that divides AB in the ratio 3:2. There is a point on AB divides AB in the ratio 3:2. We are trying to find the coordinates of that point on the line segment AB. We called it P. We said let P be the point. We said let P be the point that divides AB in the ratio 3:2. Some point on AB divides AB in the ratio 3:2. So we call it P. Now we are finding the address of P. We are finding the x coordinate and the y coordinate of P by using the section formula. So you can find the x coordinate of P separately, y coordinate of P separately. You can find y first and then x. Anyways, and you understood the values. What is x1, x2, y1, y2, mn? Simply substitute in the formula and get the answers. So x is 7, right? X is 7 and y is 3. Correct?
Yes, ma'am.
Okay, so that means P is given by the address 7, 3. P is given by the address 7, 3. See you, children. So you let the point be x, y. This is to find the x coordinate. This is to find the y coordinate. So the point is P. The point P given by the address 7, 3. This divides AB in the ratio 3:2. All right, children. So that's it for today's session. You have any questions, children? Any doubts?
No, ma'am.
No, ma'am.
Okay. In case you have to ask anything, please stay back. Else you may leave the meeting, children. Thank you.
Thank
Thank
you.
you.
ma'am.
Thank you.
Thank you, children. Good night. Good night, children.
Ma'am.
Thank you, children. Good night.